People often ask me as a theoretical physicist, when will the universe reveal its next stunning secret? My answer is simple. That moment is unfolding right now. A traveler from the darkness between the stars has arrived. If you're watching this, drop a comment below and tell us, where in the world are you seeing this video from? We'd love to know. Officially cataloged as 3IATLAS, it is carving its way through our solar system at breathtaking speed. This is not some distant mathematical theory or an abstract concept whispered about in lecture halls. This is a live demonstration of celestial mechanics, plasma dynamics, and the raw physics that shape our cosmic neighborhood. We are witnessing in real time something extraordinary. Imagine this visitor, born in some faraway star system, now drifting into the bright glare of our sun. As its icy surface awakens under intense radiation, the object begins to speak a language older than human civilization, the language of light, heat, and velocity. It moves not as a wandering rock, but as a messenger carrying with it the story of another world. This is a rare moment for humanity, not a theory on a chalkboard, but a living experiment racing across the sky. Our instruments, perched on distant worlds and circling far above the Martian surface, are already listening. Every shimmer of light, every shift in its glowing tail, every pulse of data recorded is another sentence in the story. 3IATLAS is telling us the opportunity before us is fleeting. It will not last forever. But for these precious days, we are standing at the edge of discovery, looking directly at something that came from beyond our sun. Right now, 3IATLAS is racing through our solar system at roughly 60 kilometers every single second. That speed alone is staggering, but it is only the beginning. As it dives closer to the heart of our star, its momentum continues to build. By the time it reaches its closest approach, its perihelion, in the final days of October, its velocity is expected to surge to nearly 68 kilometers each second. Picture this moment. An interstellar traveler ejected from a distant and unknown solar system is now hurtling straight toward the blazing furnace that surrounds our sun. This is a region where radiation is fierce. Magnetic fields twist and coil like living things, and temperatures rise high enough to melt even the most resilient materials. It is here in this crucible that the object's true nature will be revealed. Every second counts as it approaches this solar gauntlet. Dust, ice, and hidden materials locked deep within its core will awaken under the intense heat. Gas jets may erupt, brines may surge, or it may fragment entirely, scattering its story into countless glowing shards. Whatever happens, the sun will draw out its secrets. And when it does, our telescopes and instruments will be ready to listen. To truly follow the journey of 3IATLAS, we have to look beyond its raw speed and study the elegant geometry of its path. This is not a random dash through space. It is a carefully carved arc through our solar system, intersecting the orbits of planets, bending under the weight of the sun's gravity, and offering humanity a series of narrow windows through which we can glimpse its secrets. Now, if you enjoyed this journey through the stars, hit that subscribe button and join us for more cosmic discoveries. In the early days of October, this visitor swept past the red planet, but it moved to within roughly 1/4 of the Earth-Sun distance from Mars. That moment was more than a cosmic coincidence. It created a perfect alignment between the object, Mars, and our observing instruments scattered across the Martian sky. While Earth's telescopes will soon face the blinding brilliance of the sun, Mars stands in the right place at the right time, like a silent guardian holding the line of sight. From orbiters to rovers, every lens is turned toward this celestial messenger. Then, on the 21st of October, the dance changes. The sun will slide directly between Earth and 3IATLAS, creating what astronomers call superior conjunction. From our homeworld, the object will simply disappear. The overwhelming light of our star will swallow its faint glow, and for a moment, we'll be deaf and blind to its passage. But this is not the end of the story. It is the silence before the storm. Because as the month nears its end, something remarkable happens. Between the 29th and the 31st 3IATLAS reaches perihelion, the point in its orbit when it draws closest to the Sun. It will be moving at breathtaking speed, its surface locked in a battle with intense solar radiation. Icy material may burst free in plumes, its tail may lengthen into a luminous spear of light, or under the crushing forces it could shatter, leaving glowing fragments streaking through space. This entire sequence, the close brush with Mars, the blinding conjunction, the fiery encounter at perihelion, forms a precise cosmic choreography. Each date is a turning point. Each alignment opens a new window for discovery. And while the object hurtles forward on a path written long before humanity even existed, we now find ourselves as witnesses, listening to the universe as it speaks in the language of light, geometry, and motion. As Earth slips into its blind period, the red planet becomes our cosmic outpost. While the Sun's brilliance drowns out the faint light of 3IATLAS from our home world, Mars holds a clear and uninterrupted view. It is no exaggeration to say that the most critical data of this entire encounter may come not from Earth, but from that distant rust-colored world. Orbiting high above Mars, a fleet of robotic explorers is already on standby. The Mars Express spacecraft and the ExoMars Trace Gas Orbiter from Europe are both perfectly positioned, their instruments tuned to capture the faintest changes in light and chemistry. Every pixel, every spectrum, every flicker they record will help us decode what this interstellar visitor is truly made of. But they are not alone. Circling the Martian skies, the Mars Reconnaissance Orbiter carries one of the sharpest cameras ever sent to another planet, capable of catching subtle details in the darkness of space. Alongside it, MAVEN, the atmospheric monitor, is ready to listen to the faint whispers of gases and plasma as the object roars past. They are coordinated, multi-angle measurements designed to build a three-dimensional story of a traveler from another star system. While Earth telescopes are silenced by solar glare, this network becomes our eyes and ears. It is a remarkable demonstration of how far human technology has stretched beyond our home world. Mars, once a distant target itself, now stands as a scientific ally, allowing us to keep watching even when our own skies turn blind. In this moment, our robotic explorers are not just orbiting another planet, they are standing on the front line of discovery. In the stillness of early September, astronomers began to notice something strange. 3IATLAS wasn't behaving the way the models said it should. Its glow, faint at first, started to rise with a quiet but unmistakable intensity. As the object slipped past the 2 astronomical unit mark, the increase in brightness accelerated, climbing steadily until it reached a level near magnitude 12. That might sound small, but in the language of the night sky, it is significant. Magnitude 12 means the object, though invisible to the naked eye, can be clearly seen through modest backyard telescopes, the kind owned not just by major observatories, but by patient amateur stargazers scattered across the globe. What was expected to be a whisper of light had become a distinct voice cutting through the darkness. This surge in luminosity did not align with the initial mathematical projections. The models had anticipated a slower, steadier rise, but 3IATLAS seemed to be rewriting the script. Perhaps trapped pockets of volatile gases had begun to erupt sooner than expected, forming jets that reflected sunlight more efficiently. Or perhaps the object's surface was structurally different than we imagined, its icy crust crumbling into fine dust that brightened its surrounding halo. Whatever the cause, this anomaly matters. Brightness is more than just a visual feature. It is a language. It tells us about composition, temperature, internal structure, and behavior under solar stress. Every unexpected flare, every spike in intensity is a clue. And right now, 3IATLAS is speaking in a way that has caught the attention of both professionals and skywatchers alike. It's a reminder that in the quiet expanse of space, even the smallest shift can reveal something extraordinary. On a cold Martian night, as Perseverance turned its camera toward the sky, something remarkable appeared. In a sequence of long, stacked exposures, a single narrow streak cut across the stillness of the star field, a diagonal slash of light that refused to vanish. One frame after another, it held its shape, its angle, its motion. This was no random glitch. This was a traveler in motion. Cosmic rays strike sensors in unpredictable bursts, brief and chaotic. Satellites orbiting Mars trace smooth arcs that can be calculated and identified. But this streak matched neither. Direction, its timing, and its sharpness aligned with the predicted path of 3IATLAS as it swept past the red planet. For a rover built to search for the traces of ancient Martian life, this was an unexpected moment, a chance to catch a visitor from the stars slicing through its field of view. The image itself is not spectacular in the way a comet tail blazes across an Earth sky. It is subtle, almost delicate, but science often hides its greatest revelations in these quiet details. That thin streak is evidence, a puzzle piece fitting perfectly into orbital calculations, confirming that the object was exactly where it was expected to be, and moving as fast as the models had predicted. For the teams watching from millions of kilometers away, this single observation carries weight. It bridges theory and reality. It transforms numbers on a screen into something tangible, captured by a machine resting on alien soil. Perseverance became, for a brief and extraordinary moment, a witness to an interstellar visitor racing past Mars. And that streak of light, faint but undeniable, now belongs to the growing archive of human knowledge about this wandering messenger from beyond our sun. As 3IATLAS surges closer to the blazing heart of our star, its behavior begins to shift in ways that command attention. Scientists around the world are carefully watching as the sunlight, fierce and unrelenting, strikes its surface. What was once a silent traveler is now coming alive under the pressure of solar radiation. The leading theory is simple in concept but profound in consequence. Intense heating from the sun is awakening the frozen material buried deep inside the object. Ices locked in place for untold ages are suddenly bursting free, releasing gas and dust into space. But this is no ordinary reaction. As the solar wind collides with that escaping material, plasma interactions ignite a complex chain of events. Spectroscopic measurements are already hinting at something familiar and intriguing. Astronomers are watching for the telltale signs of C2 emissions, known as swan bands, a signature often linked to comets when carbon molecules are excited by sunlight. These emissions can create a luminous green glow, a kind of emerald halo that wraps around the object as it hurtles forward. This glow strengthens. It may reveal not only what 3IATLAS is made of, but how it's responding to the solar environment. But there's more. Alongside this growing brightness, scientists are preparing for the possibility of structural change. The intense heating, the jets of gas, the violent pressure from sunlight itself, all of it could crack or fracture the surface. The object may fragment, shedding pieces that spiral behind it like glowing embers. Or it may hold together, becoming brighter still as its envelope thickens. In this moment, 3IATLAS is no longer just a distant point of light. It is an unfolding physical drama, ice, gas, and sunlight locked in a delicate and volatile dance. The emerald glow, if confirmed, will not just be beautiful. It will be a message written in chemistry, telling us about the building blocks of a world that was born far beyond the reach of our sun. The story of 3IATLAS does not end with a single flyby or a fleeting glimpse. Its passage through our solar system is being tracked with extraordinary patience and foresight, extending far beyond the immediate observations from Mars. The European Space Agency's JUICE spacecraft, already navigating the inner reaches of the solar system, will join this grand surveillance, offering a wider perspective and extended baseline for monitoring. This is the nature of serious scientific investigation. Observing an interstellar object is not a race to capture a single moment. It is a relay that stretches across months, even years. Data collected today may not reach public archives for some time. Operational constraints, line of sight limitations, and the intricate choreography of space communications mean that portions of the DASAT might remain private until the year 2026. Yet this delay is not a drawback. It reflects the rigor of modern astronomy. Each measurement, each spectrum, each image must be carefully processed, validated, and cross-referenced with parallel observations. Only then can we be confident that what we have captured is not an illusion, a random cosmic ray, or a miscalculation in our instruments. By combining immediate observations with long-term monitoring, scientists hope to build a complete portrait of 3IATLAS. Every angle, every wavelength, every fleeting anomaly contributes to a deeper understanding of its structure, its chemistry, and its journey. In this way, patience becomes a tool as vital as telescopes or cameras. And when the full story finally emerges, we will have a rich, verified record of one of the most remarkable interstellar visitors humanity has ever witnessed. Within a single decade, humanity has now encountered 3 confirmed visitors from beyond our solar system. First came Oumuamua, a strange, elongated body that defied every expectation. Then Borisov arrived, a more familiar cometary object, yet still full of surprises. And now 3IATLAS takes its place among these cosmic wanderers, each one challenging what we thought we knew about interstellar travelers. Each of these objects tells a different story. Oumuamua passed through like a ghost, its unusual shape and acceleration puzzling scientists and inspiring countless theories. Borisov, with its icy tail and familiar chemistry, reminded us that interstellar objects can also behave in ways that echo our own comets, yet still with deviations that made it unique. 3IATLAS now continues this trend, revealing phenomena we did not anticipate: unexpected brightness surges, rapid rotation, plasma interactions, and chemical emissions that may illuminate its composition. This trio of wanderers forces us to rethink the boundaries of planetary science. They remind us that the cosmos is far richer, more varied, and far less predictable than our models often assume. Every new visitor from the stars acts as a natural laboratory, testing our understanding, refining our calculations, and sometimes overturning long-held assumptions. And in observing 3IATLAS, we are witnessing science in motion. It is a lesson in humility, a reminder that even as our instruments grow sharper and our models more sophisticated, the universe continues to surprise, provoke, and inspire. Each interstellar visitor is a teacher, and 3IATLAS has just begun its lecture. What 3IATLAS teaches us extends far beyond the specifics of its pathochemistry. This event is a window into the very essence of scientific progress. Discovery does not arrive in a single flash of certainty. It unfolds slowly, patiently, piece by piece, through careful measurements, repeated observations, and independent confirmations. It is the meticulous collection of data, the layering of evidence, and the relentless questioning of assumptions that build true understanding. In the weeks to come, as 3IATLAS disappears temporarily behind the glare of the sun from Earth's perspective, wait, we prepare for the moment it reemerges in December, transformed by its passage through the solar inferno. At that point, fresh observations will be gathered, compared with the recordings made before its perihelion, and analyzed with precision. Every shift in brightness, every spectral signature, every plume of gas or dust will be examined. These observations will not remain mere numbers on a screen. They will form the foundation of research papers, doctoral theses, and scientific discussions that may reshape our understanding of interstellar objects. Future generations of astronomers will reference the Martian imaging campaigns, the brightness anomalies, the diagonal streaks captured by Perseverance, and the spectral fingerprints recorded by orbiting observatories. 3IATLAS reminds us that knowledge is not delivered in moments of spectacle alone. It grows quietly through dedication, patience, and curiosity. The universe owes us no simplicity, no easy answers. Yet it offers consistency. And in that consistency, armed with technology, imagination, and persistence, humanity stands ready, listening intently to a visitor from the stars, learning lessons that will last far longer than the fleeting light of any comet or asteroid. Don't forget to subscribe and stay tuned. Tomorrow we'll release a brand new video, and there's so much more of the universe waiting to be explored.